Hey everyone, just thought I'd do a update on the torque mod that I had done a while ago. I did a video about it, um, basically to add more powers for hill climbing and quicker acceleration, and got about 400 miles with that mod on there. Didn't have any problems um, until the other night. We were riding, my son and I, in our area here, and we're kind of in a hilly area. So we were actually down at about the lowest elevation point of where we were riding, and we were heading uphill to go to the highest elevation point. And it's a bit of a climb and several hills to get there. So I was, the torque mod was coming into effect then to climb those hills. And basically what happened, I was going up one of the hills and I was going about 24, 25 miles an hour, and all of a sudden my throttle just went dead on me. No throttle. My display started flickering. It was at night. My display started flickering, so it wasn't like the fuse blew or anything like that, because I would expect that to just go and it's done. That's what the fuse should do. So it kind of was more like a brownout situation, which isn't good. Brownouts are not good for electronics, period. And I had turned on my voltage meter that I have wired onto my battery. That basically I replaced the USB charging port with a meter so I could see my voltage. It was a different mod I had done another time, and I got that mounted up on the handlebar. And I saw my voltage just dropping until it got to nothing, and the meter just finally shut off. So I had no power whatsoever at that point. No lights. Everything was just dead on it. Got back home and took the deck off, and basically the problem was pretty much an oversight on my part when I did the modification to begin with. I should have thought of this, but I didn't. And basically what happened is in the torque mod, I wired in a 50 amp fuse, because the standard 20 amp fuse, 25, 30 amp fuse that was in there to begin with couldn't handle the torque mod, so I kept blowing fuses. So I ended up getting up to a 50 amp fuse before to get to the point where I wasn't blowing fuses anymore. And anyway, so when I did the torque mod, this here is basically the original fuse holder that was in the scooter. This is made of rubber. This is basically it's a chunk of rubber. And when I did the torque mod, I had to, my 50 amp fuse isn't the same size dimensions as the original one. It's a bigger fuse, of course, so it wouldn't just fit in here where you could close the lid on this thing. And so what I did is I kind of basically rigged the fuse in there by pushing. I used some copper wire into the fuse, and then push the other ends of the wires into these two connectors that are inside this rubber fuse holder. So what had happened is basically, this being rubber, it has a lower melting temperature than to say the insulation on the wires themselves. And so basically what had happened is this rubber got hot enough where it started melting, and basically some of the rubber actually got down in between the connections for my fuse and these connectors here, which interrupted the connection to the fuse and caused that problem. I was a little worried at first, because when I got home, I had pulled the top off the scooter, and I measured right here on my battery port, and I didn't get any voltage, so it was completely dead. I looked at the fuse at the time, which here's my fuse still, and you can see through the window there that the fuse was fine. So I was a little worried at that point. I then pulled the fuse out of the fuse holder and ohmed out the fuse, which was good. So I thought, oh crap, I blew out my battery or the BMS board, which is right on the end of the battery here. And the BMS board is basically protects the battery from overcharging, undercharging. It's there to protect the battery. So I thought probably I blew this out, which isn't a huge deal. You can buy those. I've seen them for like 20, 25 bucks on AliExpress for the type I'd need. But it was kind of a bummer. I thought, oh geez, what happened? But then once I figured out it was this problem, the rubber melting, I'm like, well, that's my fault. I shouldn't have had that in it to begin with. I knew it was going to draw more current. I knew it was going to get hotter. The good news is the insulation on the wire itself was fine, because it's made to withstand more heat than a piece of rubber, obviously. So that was the whole problem. So what I ended up doing the next day after, it was late, so I didn't mess with it that night, but I thought I had a problem with the BMS basically. But the next day, I came home and measured again with my voltmeter. I wanted to double check, so I measured from the black lead on this connector here. And since I had my fuse out, I actually measured voltage on the side of the connector that was going to the battery, and I had 52 volts there, so that was a relief. My battery's good, the BMS is good, and I knew the fuse was good, so I knew the problem was this, right? And I don't know how good you can see this, but the connectors in there, when they got hot, melted the inside, and that's what caused the problem. Intermittently interrupted the connection to the fuse, so that's why I saw the gauge flickering and kind of creating a brownout situation. Again, brownouts are not good for electronics. It'd be better for the fuse to just blow and cut everything off than to have a fluctuation there on the current, especially when I'm going up a hill like that. So all was good and well. I put basically cut, as you can see, I cut the fuse holder out, the rubber fuse holder out. I just hardwired it. I soldered the ends of the wire from the battery and from the connector, just soldered them, tinned the ends, and then crimped them down a little bit because they wouldn't fit straight into the fuse itself. This fuse has very good clamping mechanisms on them for the wires, so I ended up just tinning the wires and then shoving them into the fuse directly instead of going through that fuse holder. And they're good and tight. But then after that, I put some heat shrink on it and did that, and then beyond that, I wrapped it up with some electrical tape. So here's my new deal. I took the fuse holder out, the rubber fuse holder, and I just got the fuse kind of hardwired into the wires. So that was all good. I put everything back together, put the deck back on. I had power, the motor ran, everything was good, and went for like a 5 or 6 mile ride. Everything was good. Next night we went about 13, 14 miles in the same hilly area. I wanted to test it again over the hills, and it was good. Had no problems whatsoever. So I figured, okay, problem solved. It was my bad. I should have thought of not leaving that hunk of rubber in there where the fuse was. That was just asking for trouble, I guess. So I thought all was good. 2 days go by. Weekend comes. Me and my son and my friend who bought one of those open box scooters, we're going to go for a longer ride, and we literally went about 1.5 miles, and we're at the point of a road where we need to cross the road, and it was like mid-road because we're riding on these canals and alongside these canals, and it crosses mid-road, but there's a crosswalk there and a don't walk button, so we push the button, and actually they went across before I did. I was waiting on the other side, waiting for the light to change the walk signal. Well, while I was sitting there waiting, there are some cars coming, and they decided they were going to stop. And once one stopped, and the other one stopped in the other lane, and it's like they stopped waiting for me, even though I had the don't walk signal. So I felt compelled. Okay, now I'm holding them up. I got to get out of their way. So I stepped on the scooter and pretty much full throttle it, to get across there. And with the torque mod, actually anytime on these scooters, the most power, the most current you're going to draw is when you're standing still and just starting, right? When you're moving and you full throttle or something like that, you're not drawing as much current as you are when you're at a dead stop. All your weight's on it. The scooter weighs 60 pounds. That's your highest power. The highest amount of power you consume is from a dead stop. So I did that. I was trying to get across the road in a hurry because I was holding up the cars. Wish they would have just gone, and I would have took the light when it changed, but I didn't. So I stepped on it, I full throttled it, and bam, cut off, just cut off like that. I was pretty upset, but anyway, ended up having to push it across the road, running it across the road, trying to get out of the way so I could go. And basically, at that point, I felt when I rolled the scooter, the back tire had resistance to it. It wasn't as free rolling as it normally is, and that's a sign of something wrong with your controller. I've had that problem before a long time ago when the way the scooter came, the wires were kind of all mashed together, wrapped with electrical tape on the controller, the power wires, and they draw heat, and so being wrapped together wasn't a good scenario. They melted some other wires, the Hall effect or control wires to to the controller, and a couple of them were stuck together. That was, that was previously, and by just separating those wires, everything came back and was good ever since. So I knew that was a sign of something wrong with the controller when your back wheel isn't rolling as freely as it should. It seems like there's resistance on it. So anyway, problem two. And anyway, what that ended up being is I ended up pulling out my controller, and these are your 3-phase wires to the motor, your motor main power. And as soon as I disconnected, I think the blue wire, the motor rolled freely. Of course, I had power, power disconnected and everything, but somehow the motor knows, and basically what I figured out is resistance. It knows the resistance that should be across these wires, and somehow the motor goes into this more resistive state when something's wrong there. Anyway, so what I did is I first took an ohm meter. I have a spare controller, which is good. I bought that when I first had a problem, thinking I had a bad controller, but ended up, getting around that so I didn't have to use a new controller. It was just a couple of wires I had to separate. So anyway, I have a new controller, so what I did is I wanted to ohm out just between these phase wires. So, for example, if I put it on the yellow, and then, sorry, my other probe here is black as well. My negative probe has the clip. The positive probe is this one in my hand. So when I put that across those two wires, I ohmed out 20K, 20,000 ohms. So yellow to green is 20,000 ohms. Yellow to blue, I'm getting 10K. And then, sorry, I'm trying to do this one-handed, and I'm using my phone again. Green to blue, I got 10K again. So I'm like, okay, let's see what my newer or good controller will do. Green to yellow, 20K. Green to blue, 20K. Yellow to blue, 20K. So everything between these 3 wires, I can measure any 2 of them, I get 20K. Whereas this one, I get 20K between the green and yellow, but between the green and blue, I get 10K, and between the yellow and blue, I get 10K. So that tells me something's wrong with the channel that this blue wire's on. Okay, so I know there's something wrong with it, and basically these 3 wires connect up to your FETs, your MOSFETs, which is, that's where your power's coming from, your current. And as you can see, there's, sorry if this is a little blurry, it's not good lighting, but there's 6 MOSFETs in this thing, 1, 2, 3, 4, 5, 6, 3 channels, 2 MOSFETs on each channel. So the green wire comes from 1 channel, yellow wire comes from the 2nd channel, blue wire comes from the 3rd channel. I suspect there's something wrong with the blue wire due to that ohming out that I just did. So the next thing I did is I turned the controllers over, and I just simply measured out those FETs, just ohmed them out, and bear with me a second. I'm going to try to do this one-handed again. I'm going to clip that on there. And hold on one second. Sorry about this. I should have somebody else filming, but I don't. Of course, earlier I was able to do this quite easily, but now I'm going to have trouble. Okay, so I think I got it. So basically, here's my new one. And what I'm doing is I'm measuring from, there's 3 pins on each FET. And I'm ignoring the center pin. I'm just measuring from the first pin to the 3rd pin. Sorry about the focusing again. Can't really help it. And I get 1.6 mega ohm. So there's some high resistance there. If I go to the next one over, and this is the green channel, green wire channel, I get about 9 meg. Okay, so I go to the 2nd channel, the yellow channel, the first FET 1 to 3. I get about the same, 1.7 ohm mega ohms, and the second one in that channel, again, I get about 9 meg. Okay, so now I'm going to the third channel, which is the blue one. Again, I got 1.7, 1.6, and on the last FET, same thing, about 9 meg. Okay, that's with the, if I reverse the polarity of my probes, I'm not going to do it now, but you get 4 meg across each one of them. I guess let me try it. So you could do it either way. One way you're going to get 4 meg across every one of them. The other way it's going to switch between 1.6 meg and 9 meg. So yeah, well, you take my word for it because I can't really do it now. So anyway, on this other one, if I measured the same FETs, the green channel comes out the same, 1.6, and then 9 meg. The second one comes out the same, 1.6, and then 9 meg. But the third one, on the bad controller, from the 2 outside pins, it's shorted, directly shorted. And then the fourth one, this is the blue channel again. Fourth one, the sixth one. So it's basically both the FETs on the blue channel from the 2 outside pins are shorted. Whereas they should be, like on the good one. Okay, I've got the probes reversed now, so I'm getting 4 meg. So now with the probes this way, on the good one, I get 4 meg across everything. And so yeah, so basically, I believe I got 2 bad FETs in this one, the 2 on the blue channel with the blue wire. These 2 here, they appear to be shorted. And that causes the resistance difference between the wires, the 20K versus the 10K, that somehow tells the motor, hey, something's wrong, and creates that resistive roll of the motor. Anyway, so I got a new controller anyway. I put the torque mod back in this one. Here's the old one. Torque mod I did was this, I used a stranded wire at that time because I didn't know how thick I needed it. And stranded wire allowed me to adjust the size of it. On the new one, I just used a copper wire. It's about the same size as the shunt that's originally in there. You can see the shunt on this side and the copper wire on that side, about the same size. I think it's, I don't know if it's 14 or 16 gauge, but that's what I used this time for the shunt, or for the torque mod. So this is my new controller. I had it wired in already, and everything's good with it, so I took it back out to make this video. I've done this so many times with the scooter, it's second nature to me, so it's not a big deal for me to do that. But I wanted to show you guys this video just to let you know I did have an issue. I don't think it was, well, it was kind of related to torque mod because it generated more heat, which melted the rubber fuse holder, which caused the inevitable problem of that. The second day after that, when this went out, I 100% believe it was a result of having that brownout effect when the fuse holder melted originally. Like I said, I put at least 400 miles on the scooter with that torque mod. I mean, going uphill, starting from a stop, never had a problem with it until coincidentally 2 days after that brownout thing happened. Basically what I think happened is when that occurred with the fuse holder and kind of went to the brownout state, I believe it compromised those 2 FETs at least, maybe even the other ones. So I think that was a result of the fuse holder melting. I don't think that would have happened. I don't think those FETs would have went out had it not been for 2 nights earlier when that occurred. Anyway, so I figured I'd try to fix this controller. I went online looking for these MOSFETs, and it's there's the part numbers written on it. I can't quite see it right now because I got my contacts in, so I can't see up close. I looked up the part number though, and lo and behold, I don't know if those things aren't made anymore. I couldn't find them anywhere, not in the United States. I looked on Alibaba or AliExpress, couldn't find them there. So I figured, okay, I'll look for an equivalent, something that's equivalent to that. So I had to do some homework on that, and I'm still not, I'm not a component engineer, so still don't quite understand all the specs on those. But I did end up coming across this same FET on a Chinese site, and so I actually ordered 24 of them, just so I have. And basically, why I did that is because the shipping, I paid $20 for 24 of them, but basically the parts weren't that expensive. Half of that cost was the shipping, and whether I got 2, 4, 5, or 20, it was the same shipping amount. So I figured, I might as well get a bunch of these, and then I'll have a bunch of them on hand should I ever need them. We've got 2 scooters. My buddy's got 2 scooters, him and his girlfriend, and so I figured if I'm going to order these from China, I might as well get a lot of them so I have them. Anyway, so that's what I did. I paid with PayPal, so just don't know when they're going to come. I did get an order acknowledgement, but no shipping notice yet. But it's right now that coronavirus thing's going on, so I don't even know if they're at work right now. So yeah, I'm in no hurry. Like I said, I got a new controller, so I'm going to I'll put that back in and I'll be up and riding. And eventually I'll get those parts, and I'll try to troubleshoot this thing more and replace those 2 FETs, and heck, maybe I might just probably should just replace all 6, which, now that I think about it, I think I'll do that just because I believe these 2 were compromised by that brownout situation. If they were compromised, maybe they're the first ones in the chain, but these could very well be compromised too, and so I guess since I have so many, I might as well just replace all 6. And see if I can get this controller up and running again. If I can, then that's good news. I'll have another spare controller. And so that's about it. I just thought I'd do this video to let you guys know I did have an issue. I think it was, from my own negligence of keeping that rubber fuse holder in there when I should have thought about it. I knew it was going to be pulling more power. I knew it was going to be creating more heat, and I just didn't think about what I was using here to connect my fuse, having a lower melting point than like, for instance, the insulation on the wires. Again, the wires are all fine. No sign of any stress or anything on the wires. They're perfectly fine. So it was just the rubber was the lower melting point, started melting, and then that intermittently interrupted my connection to the fuse, causing that brownout situation, which inevitably a couple days later ended up costing me a couple FETs on my controller, and a little bit of a hassle having to wait there. And my buddy and my son rode back, got my truck, and brought it back. So we were planning on going on a longer ride. It ended up only being about a mile and a half, and so we just went and had a couple beers after that. So that's not too bad either. Anyway, that's about it for now. Just wanted to let you guys know that if you do the torque mod, cut this thing out of there. Don't use this. Get the rubber out of there. Just hardwire your fuse like I did to the directly to the battery and to the connector, and nothing there should melt now. It's should be good to go. Get my new controller in there. Everything should be fine. All right, guys. Sorry about that. I think I had you up there upside down for a minute there. Thanks for watching. Again, I have no qualms about doing the torque mod again. I put it on a new controller. I'm so used to having it now and having that power. It's just I don't want to go without it. So did the torque mod again. I don't expect to have any problems with it after this. I totally think my problem with the controller now is again caused from having that brownout situation and compromising the FETs in that thing. Anyway, that's about it for now, and have a good one. See you.